everyone. Welcome to my short presentation about Network Function Virtualization NFV. I'm Ghasem Mirjalily, Professor of Telecommunication Engineering and Senior Member of IEEE. Okay, let's start. What's the problem? The problem is that current networks are heterogeneous and very complex. They are composed of many different types of hardware appliances from different vendors. For example, consider the Deutsche Telecom network that covers 12 countries in Europe. This heterogeneous network is composed of about 500 different applications for monitoring and management, about 100 data and network operation centers, 48 different service types, and more than 20 messaging platforms from different vendors, and about 1,500 core routers of many different types from 6 different vendors, as you can see here. As current IP networks are heterogeneous and complex, it's hard to manage them because each individual device needs to be configured by low-level vendor-specific commands. On the other hand, today there is an exponential growth in user demands for new high-quality services. This means installing new devices and configuring them day by day. And this needs space, power, money, technical knowledge. So the expenses of the operators are growing up rapidly, while there is a competition between different providers to decrease the prices paid by the users. So they must find some new ways to provide low price, high quality services by decreasing the complexity and by decreasing the expenses. Recently, the solution is found, and it's network softwarization. That means using software techniques instead of hardware, because software is more flexible and more agile. So today, the telecommunication industry is moving toward IT industry to embrace IT techniques and IT methods. One of the well-known softwarization techniques is virtualization that has been used for many times in different areas, for example, in operating system virtualization, in cloud computing, in implementation of virtual networks, in data center facilities, And now we are going to use virtualization in telecommunication networks to replace the expensive physical devices with its virtualized software versions that can be run on a standard high volume servers, on storage facilities, on switches, on routers. These virtualized network functions can be chained together to create communication and network services. That's named service function chaining. And we will discuss it in next video, in next presentation. Okay. Many of the famous network functions can be virtualized. As instances, see this table. As you can see here, in recent years, the software version of many of these functions are produced by software companies. For example, the different functions of evolved packet core, as known as EPC, and IP multimedia system, IMS, that are two main parts of LTE mobile networks, are virtualized, as you can see in these tables. Here in this slide and next slide, some successful implementation of virtualized EPC and IMS are shown. For example, Vodafone in collaboration with Huawei and South Telecom in collaboration with Samsung have implemented NFV in their communication networks. However, the virtualization is not happen overnight. It needs time, and usually countries have a roadmap for migration from current devices to its virtualized version. Here you can see the roadmap planned by Deutsche Telecom. It has two phases, and now we are at the seed phase, when academic research is very important for telecommunication companies in this phase. Okay. NFV has a big market, and its market is growing up rapidly. There are some pioneer companies in this market: Cisco, Huawei, Alcatel-Lucent, Cloud NFV, HP, and others. Now let's review the history of NFV. NFV was introduced for first time in October 2012, and in November 2012 the ETSI NFV Special Interest Group was founded to provide the definitions and the architecture. The first formal definitions of NFV and its architecture have been introduced by ETSI in 2013. The ETSI NFV architecture is composed of 4 building blocks. The first part is NFV infrastructure, NFVI, that consists of hardware and virtual resources, including virtual machine, virtual links, virtual nodes. The second part are virtualized network functions and their related management system, named EMS. The third and most important part is MANO. That's the abbreviation for NFV management and orchestration. MANO is responsible for service provisioning and configuring the NFVs and related virtualized infrastructure. And finally, the last part is operations and business support system, that's responsible for billing, for ordering, for troubleshooting, and issues related to the customers. In this table, some of the standard organizations in the field of NFV is introduced. The main ones are ETSI and IETF. As you can see, each organization is focused on a specific area. In this slide, you can see some important projects for researching on NFV. One of the most important projects is OPNFV. The OPNFV is launched on 2014 by a consortium of telecommunication companies, and its leader is Linux Foundation. The main mission of OPNFV is building an open source reference platform for NFV. The OPNFV project is focused on the lower layers of the NFV architecture. On NFVI, NFV infrastructure, and Virtualized Infrastructure Manager, VIM. That's a part of the model. Okay. Here are some products that are developed by the main companies: Cisco ONS, Huawei Open Lab, HP Open NFV, Alcatel Cloud Band, and others. And this is a survey article that's written by me and Professor Luo from Chinese University of Hong Kong in Shenzhen. For more information on NFV and Service Function Chaining SFC, please refer to this article. It's published on 2018 and it's now available for reading. Okay, if you want to stay in touch with me, I have my email address linked in the description of this video. Thank you.